Good afternoon, students. Welcome to the 54th lecture of fluid mechanics subject. So we are in the unit 4 discussing about various types of flow measurement devices, that is venturimeter, orifice meter and Pitot tube. So we have successfully completed the introduction of the venturimeters, the problems. Today in this session, we will discuss about the introduction of orifice meter and Pitot tube, right, and their problems. So in the last class, we have stopped this topic in the orifice meter concept. So we will discuss some of the problems in this orifice meter and we will go to the Pitot tube, right? So what's the meaning of orifice meter? It is also a device used for measuring the rate of flow of a fluid through any pipe. So it is cheaper device when compared to the venturimeter. This also work on the same principle as that of the venturimeter. So it consists of a flat circular plate which has a circular hole. So if this is a circular plate, in this we are having a circular hole, right? This plate is fixed inside the cylindrical pipe, right? So this is called an orifice. So you see the physical diagram of the orifice meter. So at this point you are having this plate. So this is the direction of the flow of the fluid. There is the exit flow. This is a vena contacta. Vena contacta means where you are having the compression place. See here, the orifice meter is essentially a cylindrical tube that consists of a plate with a thin hole in the middle. The thin hole essentially forces the fluid to flow faster through the hole in order to maintain the flow rate. The point of maximum convergence, there is a convergence, there is a vena contacta, which occurs slightly downwards from the actual physical orifice. That is the reason why the orifice meters are less accurate when compared to the venturimeter, as we cannot use the exact location and diameter of the point of the maximum convergence calculations. Now, see the next one. Beyond the vena contacta point, the fluid expands again and velocity decreases as the pressure increases. So, from the diagram, when you get any question about the derive the orifice meter annappudu, you have to draw the figure and you have to write this derivation. Let d1 is the diameter of the section 1, p1 is a pressure at the section 1, v1 is a velocity at the section 1, a1 is a area at the section 1. Next, d2, p2, v2 and a2 are the corresponding values at the section 2. Now applying the Bernoulli's equation at the section 1 and 2, we get pressure energy plus kinetic energy plus datum energy. Pressure energy, kinetic energy and datum energy. That is P1 by rho g plus P1 square by 2g plus Z1 is equals to P2 by rho g plus P2 square by 2g plus Z2. Okay. Now, so P1 by rho g plus Z1 minus P2 by rho g plus Z2 is equals to kinetic energy is the separate చేయాలి. Now H is equals to V2 square by V2 square minus V1 square by 2g. Therefore, V2 is equals to this one. Okay. So with this formulas, we will derive some of the problems. Okay. Now see the first problem. Already I have done the first problem. We'll see the second problem. A pressurized tank of water. A pressurized tank of water has 10 centimeters diameter orifice. So see here. So it is having an orifice of 10 centimeters. We are having an orifice that is 10 centimeters orifice here. At the bottom of the tank, where the water discharges to the atmosphere. The water level is 3 meters above the outlet. So outlet ఇది కదా, outlet నుంచి water level ఎంత ఉంది, 3 meters height ఉంది. The tank air pressure above the water level is 300 kPa, while the atmospheric pressure is 100 kPa. అంటే ట్యాంక్ లోపల ఈ బ్యాలెన్స్ లో ఉన్న అట్మాస్ఫియర్ is 300 kPa, thereby the atmospheric pressure is 100 kPa. 100 kPa. Neglecting the frictional effects, determine the initial discharge rate of the water from the tank. Okay. Now, so you see here, so apply the Bernoulli's equation. P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. That implies V2 square by 2g is equals to derivation, this one, right? This derivation. Okay. So V2 square by 2g is equals to this one. Now applying this one, V2 is equals to root of 2 into pressure difference P1 minus P2 by rho plus 2 into g into Z1. Then P1 and the 300, this one 300. P2 is equals to 100. P2 is equals to 100 divided by rho is equal to 1000 into 2 into g Z1. So applying this one, 2 into g into Z1 and the Z1 is this one, height. Z1 is equal to height here. Okay. Now after substituting the values, you are getting velocity V2 is equals to 21.4 meter per second. Therefore, V is equals to, what is V? Area of the orifice into V2. That is equal to area is equal to pi d square by 4 into V2. Pi into what is d square here? 0.1, 10 centimeters and 0.1 meter square by 4 into వచ్చిన value 21.4. The answer is 0.168 meter cube per second. So like this you have to do the problem, right? So what is this one is kPa, kilopascals కాబట్టి kilo కి 1000 into pascal, 1 kg per meter square. Next, see the third problem. The water level in the tank is 20 meters above the ground. So this is the tank. Water level of the water is 20 meters. The water level in the tank, is 20 meters from the ground. Ground దగ్గర నుంచి water level of the water is 20 meters. A hose is connected to the bottom of the tank. See the figure, the hose pipe is connected to the bottom of the tank, and the nozzle at the end of the hose is pointed straight up. So the hose pipe అనేది ఇలా డిజైన్ చేసి దీనికి nozzle fix చేశారు, right? Now the tank cover is airtight. So here it is a closed tank, airtight, and air pressure above the water surface is, so ఈ మధ్యలో గ్యాప్ ఉంది కదా, దీని మధ్యలో air pressure is 2 atmosphere. The system is at sea level. Okay, atmospheric pressure is at sea level. Determine the maximum height to which the water stream could rise. Determine the height of the maximum height to which the water stream could rise. So stream అనేది, సో ఈ సెటప్ లో ఉన్నప్పుడు maximum అనేది వాటర్ డిశ్చార్జ్ ఎంత జరుగుతుంది అంటే హైట్ కొనుక్కోమని చెప్పాడు. Now applying the same formula, the Bernoulli's equation. So first write the given data. Okay, given data, P by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. That implies P1 by rho g plus Z1 is equals to P atmospheric by rho g plus Z2. That is equals to Z2 is equals to P1 minus P atmosphere by rho g plus Z1. That is equals to P1 gauge by rho g plus Z1. Okay, now therefore Z2 is equals to, and the chadipura is given as 2 atmospheric. So therefore 2 atmospheric divided by 1000 kg per meter cube into 9.81. 9.81. So then what is the datum line? H is equals to height H is this one. H is equals to 20. So to solve this one, we are getting 40.7 meters. That is a datum energy. ఇది Z1 అన్నప్పుడు ఇది Z2 కిందకి వస్తుంది అన్నమాట. Now see the next, where you are using oil. Oil of specific gravity 0.82 discharges from a open tank. So the tank అనుకుంటే tank ఇక్కడ small aperture ఉంది. The orifice is the diameter 14 mm and the height of the tank is the height of the oil is from the ground is 0.9 meter. Therefore, it is discharging 0.82 from the open tank through an orifice of diameter 14 mm. To the orifice of diameter 14 mm. The coefficient of velocity is 0.88. The coefficient of velocity is 0.88 and the coefficient of contraction is 0.62. The center of the orifice is at the depth of 0.9 meters from the surface of the oil. Now determine the diameter of the vena contracta and the volume flow rate of the oil through the orifice. So what's the given data? Specific gravity is 0.82, diameter is 0.014, the coefficient of velocity is 0.88, coefficient of contraction is 0.62, then h is equals to 0.9. Therefore, a is equals to pi d square by 4. Therefore, pi into v into square by 4, that is equal to 1.54. Now, cc coefficient of contraction is equals to area c by area o. Substituting values, cc value into 0.62, then area is the area of this one, area of contraction by area of this orifice. Therefore, area of the orifice is 1.54 into 10 to the power of 4. Now, AC is equals to area is equals to 0.955 or DC is equals to 0.01102 mm, that is 11.02 mm. So area C వచ్చింది కాబట్టి diameter ఎలా కనుక్కున్నాము? Area is equal to pi d square by 4. So d ని తీసుకొస్తే area into pi. So like this you have got the diameter. Next problem, theoretical velocity. So this is a determine the diameter of the vena contracta and the theoretical velocity. V is equals to root 2gh, 2 into 9.81, h is equal to 0.9, that is equal to 4.2. Then the theoretical volume flow rate, theoretical volume discharge is equals to V into A, that is 4 into 4.02 into 1.54 into 10 to the power of 4, that is a value. Therefore, the coefficient of volume flow rate CD is equals to CV into CC into CV, that is 0.88 into 0.62, that is equal to 0.546. Actual volume flow rate is equal to CD into critical volume. So substitute the values. So keep on solving, we are getting this one. Next one, we'll see the problem. See this figure. So a tank is shown. Find the time required to drain the tank. Okay, simple real-time application. For example, if you want to clean your tank, మీ ఇంటి పైన ఉన్న ట్యాంక్ ని క్లీన్ చేయాలి. So whenever you want to clean your tank, so you will open the drain. So then you have to see how much time it is moving. So it all depends upon the dimensions of the tank, the type of fluid, right? Like this. Find the time required to drain the tank from the level of 3 meters to 0.5 meters. అంటే 3 meters యాక్చువల్గా 3 meters నుంచి point h1 is equal to 3 meters and h2 is equal to 0.5 meters వచ్చేంత వరకు you have to find the time. The tank has a diameter. So tank diameter and the tank has a diameter is 1.50. So this one diameter is a 1.50 and the nozzle diameter is 50 mm. So this DJ nozzle diameter is a 50 mm. Now what's the given data? The area of the tank, dt వచ్చేసి 3 meters. Therefore area of the tank is equals to pi d square by 4, that is equal to pi 1.50 into square by 4, that is equal to 1.76. Then aj is equals to pi into d square by 4, that is equal to this one. Now differentiate these areas, that is at by aj is equals to 900. Then T2 minus T1, that is equals to, what is the formula? T2 minus T1 is equals to 2 into AT by AJ divided by rho 2 into root 2G H1 half minus H2 half. Therefore, T2 minus T1 is equals to 2 into 900 root of 2 into 9.81. That is H1 and this is equal to 3, H2 is equals to 0.5. This one. So after substituting these values, we are getting T2 minus T1 is equal to 417 seconds, right? So like this, you have to do the problems. So the 400 seconds converting into minutes, we are getting the minutes value. Next. Next one. The actual velocity of a liquid issuing through a 7 centimeter diameter orifice fitted in open tank is 6 meters per second under a head of 3 meters. If the discharge measured in the collecting tank is 0.20 to 0.020, calculate what? Calculate the coefficient of velocity, coefficient of contraction, and the theoretical discharge through the orifice. Then what is the first point here? Flow velocity in the orifice V is equals to Cv into 2gh. That is, what is the V here? V is equal to 6 meters. 6 meters is equal to Cv into root of 2 into G into H is 3. Head is 3. Therefore, Cv value manaku vachindi. Then what is the actual discharge? Q is equal to Cd into root 2gh. Therefore, Q is equals to already manaki icharu. Collecting tank discharge is 0.20. 0.020. 020 is equals to Cd pi by 4 into d square. So what is d here? 7 centimeters. 7 by 100 square, right? Into 2 into 9.81 into 3. Now the coefficient of discharge is 0.6774. 0.6774. Then therefore, so ఇవన్నీ substitute చేస్తే CD value మనకి ఎలా తెలుస్తుంది? So keep on substituting. This is coming down, so this is coming this side. So you are getting the CD value is this one. Then what is the coefficient of contraction? CC is equals to CD by CV. So we got CD value, we know the CD value. So substituting this one, we will getting the coefficient of contraction is 0.7424. Very simple problems, right? Understood? So very simple and straightforward problems. Now see the next problem. The water of head 9 meters is flowing through an orifice of 60 mm diameter. The coefficient of discharge and the velocity are 0.6 and 0.9 respectively. Calculate the actual discharge to determine the actual velocity at linear contraction. Therefore, area కనుక్కోండి pi d square by 4, that is equal to, what is the d here? Pi 6 square by 4, that is equal to 28.27. Then what is the q here? Q is equals to a naught into 2gh 1 by 2, that is equal to a naught ఎంత వస్తుంది? A naught is equal to already మనం కనుక్కున్నాము, and 2 into g into h value. H is equals to 9 meters. Okay, 9 meters. Okay, into 1 by 2, that is equal to values centimeters to convert చేసాం. Now determine the actual velocity. QA, actual velocity QA is equals to CD into Q, that is equals to CD value 0.6. Discharge and the velocity of this one, right? 0.6 into Q and this one. Apply this here, so you are getting the discharge. Now what is V here? V is equals to 2 into G into H 1 by 2, that is equal to 2 into G value 9.81 into H. So you are getting this value. Therefore, VA is equals to CV into V. That is 0.9 into V, that is 1328. That is a 1195.95. Got it? So like this you have to do for the contractor problems. Next. Coming to the next problem, a swimming pool 10 meters long, 6 meters wide, which holds the water to a depth of 1.25 meter. The water is discharged from the pool through the orifice at its bottom. The area of the orifice is 0.30 meter cube and the coefficient of discharge is 0.62. Determine the time required to completely empty the pool. Therefore, at the given data, area is equals to 10 into 6, that is a 60, 10 into area, 10 into 6, 60 meter square. Therefore, what is the area of the discharge? That is area is equals to 0.23, right? The area of the orifice is 0.23. And what is the head height? That is 1.25 meter. H2 is a 0. Therefore, what is the time taken? Time is equals to 2 into 80 root H1 minus root H2 by CD into A naught, A orifice into root 2G. So substituting these values, 80 మనం already కనుక్కున్నాము, root H1 1.25 divided by CD value is 0.62. See, the coefficient of discharge CD is equals to 0.62 into 0.23 root of 2 into 9.81. T is equals to 212 seconds. So this is the formula for this time taken for time 200 seconds. So like this you have to do the problems for this orifice meter, right? So hope you understand. Number of problems మనము derive చేసాము, more than 5 problems, that is 6, 7, total 8 problems మనం discuss చేసుకున్నాము regarding this orifice meter. And also we have discussed more than 3 or 4 problems in venturi meter problems also, right? So these are very simple problems. So for every type of this orifice meter, Pitot tube and venturi meter, the Bernoulli's equation is must. So time కనుక్కోవాలన్నప్పుడు ఈ ఫార్ములా యూస్ చేయండి, రైట్? సో డిశ్చార్జ్ కనుక్కోవాలన్నప్పుడు యాక్చువల్ వినా కాంటా అప్లై దిస్ ఫార్ములా. ఇంకా రిమైనింగ్ అన్నిటికీ కూడా సో హియర్ ఆల్సో సేమ్ టైం కూడా సేమ్ ఇదే ఫార్ములా. సో ఫర్ ఎవ్రీవేర్ యూ కెన్ సీ the Bernoulli's equation, right? Bernoulli's equation. And CC, even చిన్న చిన్న formulas you have to practice while doing the problems. Now the next third one is Pitot tube. Pitot tube is also similar to that of this venturi meter as well as orifice meter. It is also a measuring device, right? It is a device for measuring the velocity of the liquid flowing in a pipe or open channel. As the shown figure, it consists of a glass tube bent 90 degrees the short length. See here, this is a glass tube which is bent at the 90 degrees, and the one end is in the water, other end is towards the atmosphere. The lower short end of the Pitot tube is fit to the face of the direction of the flow. Then what is the principle of this Pitot tube? If the velocity at any point decreases, the pressure will increase. Okay, the pressure is increasing. If the velocity at any point decreases, the pressure will increase due to the conversion of the kinetic energy into the kinematic energy, pressure energy. Now the liquid rises in the tube. Due to the pressure of flowing fluid. The rise of the liquid is measured to calculate the velocity of the flowing fluid. See here, the flowing is like this. So it is rising the head. So the H is inside the water. From the ground level to the top wards, it is a rising head. So 0.2 is just the inlet of the Pitot tube. 0.1 is far away from the tube. So when you want to do the derivation by taking this figure, so let us consider, let P1 is equal to pressure at section 1, P2 is equal to pressure at section 2. V1 is equal to velocity at section 1. V2 is equal to velocity at section 2. H is equal to depth of the tube in the liquid. Small h is equal to rise of the liquid in the tube above the free surface. So it is depth of the liquid. Small h is equals to rise of the liquid. Now applying the Bernoulli's equation. So P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. But here datum line మనకి same ఉంది కాబట్టి here datum line is same. Z1 is equal to Z2 and we are not calculating the final velocity, that is Vt is equal to 0. Therefore P1 by rho g is equals to pressure head at 1 is equal to h. Therefore pressure head at 2 h plus h total తీసుకోవాలి. Substituting the values in the Bernoulli's equation, we get h plus v1 square by 2g is equals to small h plus h, that is equal to v1 is equal to root 2g h. This is the theoretical velocity. Actual velocity is given by v actual is equal to cv into root 2g h, where cv is a coefficient of Pitot tube. So hope you understood. So this is a theoretical value, this is a actual velocity. Now we'll do some of the problems. A Pitot static tube is used to measure the velocity of air flowing through a duct. The manometer shows a difference in the head 5 centimeters of water. If the density of air and water are 1.13 kg per meter cube and 1000 kg per meter cube, determine the velocity of the air. Assume the coefficient of a Pitot tube is 0.98. So taking the flow velocities, v is equals to cv into 2 root 2gh p of p minus 1. By seeing the question, first write the given data. Okay, first write the given data. Next, cv is equals to the coefficient of Pitot tube మనకి 0.8 తెలుసు, 2 into g మనకి తెలుసు. What is hm? hm is equals to 1.13 kg కాబట్టి taking the ratio of, that is 1000 by 1.13 minus 1 into 5 by 1000. What is the 5 here? 5 centimeters. Centimeters kabatti by 100 meters long తీసుకోవాలి కాబట్టి. So after substituting this one, we are getting 28.86. Next, a Pitot static tube is mounted on an aircraft traveling at a speed of 300 kilometers per hour against a wind velocity of 20 kilometers per hour. If the specific weight of the air is 12 Newton per meter cube, determine the pressure difference the instrument will register. So write the given data. So write the given data. Now what is the aircraft velocity? Velocity is equal to 300 into kilometers and 1000 divided by 3600, that is equal to value. And what is the wind velocity? The wind velocity is 20 kilometers per hour. 20 into 1000 by 3600. అంటే 60 into 60 కదా, హవర్ కాబట్టి కన్వర్ట్ into సెకండ్ తీసుకుంటే మనము 60 into 60 3600, that is equal to 5.56. Then what is the relative velocity of a plane? V is equals to, relative velocity is aircraft velocity plus wind velocity, that is 88.89. సో ఇక్కడ మనము వాటర్ బదులు ఎయిర్ ఇచ్చారు. Then velocity recorded by the Pitot tube is equals to V is equals to, this is the critical value, V is equals to cv into root 2gh. So what's the velocity? We got 88.89. cv is equal to 0.98, root of 2 into 9.81 into h. So solving for hv is the head of the air. H air is equal to this one. Then what is the delta p? Delta p is equals to 4.h into 12. So why? Because the specific of the water is 12. Therefore 5032 Newton per meter cube. So like this, you have to do the problems in the Pitot tube. So in the Pitot tube, the simple formula you have to keep in mind is V is equals to cv into root 2gh. Okay. So like this, you have to do the problems in this Pitot Tube. So with this, we'll complete this flow measuring devices. So from the next class onwards, we will start the another topic, that is about the orifices, right? What is the meaning of an orifice? What are the various classifications of orifices? What is a small orifice, medium orifice, large orifice, and their problems? And also you're having the notches, vias, and ogis, right? So once this class is completed, I will post this video. I'll post this video in the YouTube channel. Later, the link is forwarded to you so that you can share the link to other students also, right? So if you have any problems, so that you can talk to them, unlock your mic and you can talk to them. So these are very simple problems for this flow measuring devices, right? Pitot tube problems, meter problems, and orifice meter problems. Any doubts? Tomorrow we'll discuss this classification of orifices. So we have completed up to here. We have completed up to here. Next one is classification of orifice, small orifice, large orifice, and classification of notches, right? Flow of fluid through rectangular notch, flow of fluid through triangular notch, flow of fluid through trapezoidal notch, and flow of fluid through the stepped notches and their applications. Next topic to be discussed is vias and vias. So what's the meaning of via and how does the derivation takes place? So by within 10 classes, approximately 10 classes, we can complete this unit 4 also. Understood? So if you have any doubt problems, just you can ping me and you can share your problems. So these are very simple problems so that you can easily understand the concept. So practice this problem so that it will be very easy for you. So you are having 3 concepts in the unit 4. That is your flow measuring devices. Next one is your nozzles, notches, and vias. So in the 4 categories, your flow measuring devices ki problems ఉన్నాయి, notches ki problems ఉన్నాయి, nozzles ki problems ఉన్నాయి, notches ki problems ఉన్నాయి, and also for your what's the fourth one? Vias. For vias also you are having the derivation and the problems. Hope you understood my problem, right? So for tomorrow, we'll start the orifice class. Okay. Yes. So in all these cases of this venturometer, orifice meter, and pitot tube, you are having the basic common formula is your Bernoulli's equation. Okay, Bernoulli's equation. So the application of the Bernoulli's equation, nothing but this, the types of venturometers, the types of orifice meters, and the types of this pitot tube. Okay, so directly applying the Bernoulli's equation, and for some problems, time related, what is the time calculation? You have to go for the time concept like this, or you can directly take this formula, this same formulas, this formula, that formula is same, right? So the Pitot tube. So if you want to get any derivation, this is a figure, simple figure where you are having a 90 degrees. So 90 degrees glass tube, 90 degrees glass tube. So this is the derivation of this Pitot tube, and here also we are using the Bernoulli's equation, and we are finding the coefficient value, coefficient of this Pitot tube. So here is a one theoretical value, that is V1 is equal to root 2GH. Here for the actual value, CV into root 2GH. So based on this, we will get some of the problems, right? Right. So let's stop the class here. We'll continue the class in the next session. So thanks for listening to the class.